The objective of this lesson is to use understanding of circles and angles to solve a multi-step problem. Students should also be able to describe and justify their solutions as correct. For this lesson, students will learn how farmers use a circular watering system for crops. They will need a knowledge that the total circumference of a circle equals 360 degrees. As a review, they know that a ray is a line with an endpoint on one end and an arrow on the other end. In this task, the ray's endpoints are placed in the center of the crop circle. Lastly, students will use a protractor to measure their angles. Let's get to it. We have been asked to create our own circle of crops. We get to choose from 3 to 5 crops to plant in our entire circle and figure out how long it will take to water them all. Here is the chart we will use. What? No Brussels sprouts? Oh well. Let's choose the next best thing to Brussels sprouts, sugarcane. Let's also plant wheat, potatoes, and corn. Sounds like we could make a delicious dinner with our harvested crops. Using the given circle, we need to divide our circle into 4 sections. 1 section for each crop, sugarcane, wheat, potatoes, and corn. How big should we make them? Well, thinking about a pie divided into 4 equal parts would be the easiest. But we could draw our rays in just about any size, as long as we have the 4 sections for our 4 crops. So let's put our end point for our first ray on the center point and draw out beyond the circle like this. Let's do the same for the next ray. We want plenty of wheat for our dinner rolls, so let's make this section the biggest. We won't need as much sugarcane, so let's make the next section our smallest. We might need the same amount of potatoes and corn, so let's try to make these 2 sections somewhat equal in size. Now that we've got our circle filled with crops, let's find out how long it will take to water each section of crops, then add all together to find the total time from start to finish. Let's make a table and label our sections crop, angle measure, minutes, and total. Let's start with the wheat section first. Looking at the given chart, wheat takes 5 minutes to water per 1 degree of rotation. Using our protractor, place the center hole on the center of the circle. Line up one of the rays with 0 degrees and see what degree the other ray is located on. It looks like we have 130 degrees of wheat. Let's write the degrees and multiply it by 5. 130 times 5 equals 650. It will take 650 minutes to water the wheat. Now let's figure the watering time for the sugarcane. First, let's measure the angle for the sugarcane, and it looks like we have 50 degrees. Let's write that in our table. Sugarcane takes 9 minutes per each degree of rotation, so we need to multiply 50 by 9. 50 times 9 equals 450. It will take 450 minutes to water the sugarcane section. Let's measure the potatoes and corn. Looking at the protractor, both the potatoes and the corn measure 90 degrees. Let's put that information in our table. Looking at our table, we need to multiply the 90 degrees by 8 minutes to find the time to water the potatoes. 90 times 8 equals 720. It will take 720 minutes to water the potatoes. Finally, we need to find the time it will take to water the corn. 90 times 6 equals 540. It will take 540 minutes to water the corn crop. Let's look at our work to justify our answers. We first notice that although the wheat has the greatest measure of 130 degrees, it is a smaller amount of time than the potatoes. Does that make sense? The wheat is multiplied by 5 minutes while the potatoes are multiplied by 8 minutes. 5 is close to 4, so the amount of time is almost doubled for the potatoes. So yes, it does make sense for the potatoes to take more time for watering. All that's left to do is to compute the total watering time by adding all 4 watering times together. 650 plus 450 plus 720 plus 540 added together make 2,360 total minutes. How many hours is that? 2,360 divided by 60 equals 39 hours and 20 minutes to water all the crops. The only thing left to do now is to calculate how long it is until dinner time. The objective for this lesson was to utilize understanding of circles and angles to solve a multi-step problem. We met this objective by completing a task using the real-world example of crop circles. We created several angles within a circle using rays. Next, we used both multiplication and addition to solve the amount of time it would take to water our entire circle of crops. We also checked to make sure our calculations made sense and justified our answers to be correct.